Hello, I'm Robin Vincent and welcome to Surface Sessions. Today I can announce the arrival of my long-awaited Surface Pro 2017 performance video. It's here, it's finally here, and it's been an intense journey. It's taken me weeks, it feels like, but we're there for the Surface Pro 2017, which is this lovely fella here. Oh, that's so soft. It's time to find out what it can do. So benchmarks then, yeah? Well, no, I hate benchmarks. They're the worst possible way to measure a computer's ability to do music production. It has no relevance. If you run a piece of benchmark software and it gives you a nice figure as to what the CPU is capable of, that has no relevance to how many plugins, how many virtual instruments, whether you can do audio recording. None at all. Because the power of the CPU has nothing to do with the ability of the system to get that power to do real-time audio glitch-free streaming. The other problem is that unless you have exactly the same system with exactly the same version of Surface Pro, exactly the same audio interface, running the exact same plugins, then you can't actually compare because there are so many variables. You have variables in performance with the CPU speed, you've got variables with the quality of the audio driver between the audio interface and the surface. You've got the kind of plugins that you're running, how intense they are, how much CPU each instant uses, whether you can use one instance every time or whether you can build in multiple instruments within a single instance. All of these things have an impact on your computer's ability to do music production and to do real-time audio. And so there is no defining benchmark that I can give you which will say the Surface Pro 2017 can do this. It's no guarantee. All I can do is demonstrate, is show you the sort of things it can do. I can give you a few plugin counts and compare that to the Surface Pro 4, and I can give you an idea of what it's like to run the Surface at sort of 95% CPU. But how you use that information to judge your own system and your own setup is entirely up to you, and your mileage may vary. Just because I got so many plugins out of one particular software, with a particular plugin, with a particular interface, on this particular surface, it doesn't mean that you will. So bear that in mind. However, what I hope I've achieved with this video is a demonstration of what is possible, what it could do, what in extreme circumstances you could push it to, and with a bit of luck, you'll be able to see whether it has the power to do what you need it to do. Enough talk, let's get on with it. Before we start crunching those plugins, let me just show you what the setup is. Now this is the Surface Pro 2017. It's the i5 model, 8GB, 256GB of storage. It has no fan, it's completely fanless and passively cooled. That might be interesting. I have it connected via here to a powered USB hub up here. I had a little bit of trouble with hubs in an earlier video, you might want to look that up. So to try to keep things simple, I'm going with a USB 2 powered hub that I know has been working well for a long time. Into that, I've got my Cubase dongle, my Pro Tools iLock. I'm running the Base Station 2 controller keyboard here. I'm not using the synth, I'm purely using it as a MIDI controller to send MIDI into the Surface to test that kind of thing. And the other thing connected is my audio interface, which is this, the Avid Fast Track Duo. Been using it for a long time. It seems to work really well in most situations, and that is what I'm going to be demonstrating and testing with the system in this video. I have used other audio interfaces. I have tested it with my K-Mix, with my Steinberg UR28M as well, but I don't want to show everything because it just takes far too long. So I'm going to stick with this. I'm going to be running it for the most part at 128 samples, which reveals about 5 to 6 milliseconds of latency within the system, which is excellent. And in fact, this audio interface will go down to 64 samples without too much more impact on the CPU. And that neatly highlights why you need to be using a USB audio interface. I've done a video on using the onboard sound a little bit, and I'll do another one a bit more detailed on it. However, you will always get the best performance. You will always get the lowest latency, at least in my experience, using an audio interface with ASIO drivers plugged into a USB port, all ready to go. Now, of course, if you're using a different audio interface, then you may get different results. The quality of the driver that runs that interface is vital to the performance you get out of any system. So again, and I'm sure I'll say this lots and lots and lots, that this is just designed to give you an idea. I can't tell you exactly how many plugins it'll run, exactly what the DAW performance will be, unless I have exactly the same system as what you're running. So everything we see here has to be treated as an example, as a demonstration of potential of what your system could possibly do. Similarly, if you have the i7 Surface Pro, it'll probably do a bit more. If you have the more entry-level i5, it will probably do a bit less. And if you have a completely different system, say an Asus or a Lenovo one, then I have absolutely no idea, because all I'm using here is the Surface. So all I can really demonstrate is what my Surface here is doing through these bits of hardware, through my hub, and with the software I'll be showing. When doing performance testing, it's always useful to look at comparisons. So I will be running comparative tests on the Surface Pro 4, just so you can see how the two run side by side. We'll be looking at everything that happens at that bleeding edge of CPU power and how best to cope with it on the Surface Pro 2017. It may raise questions. We don't know. I may have answers. I may not. We're going to have to see as we go. The other thing people always ask about is latency mon. Yes, people are always saying, hey, you should run latency mon, and that'll show you what is wrong with your system and enable you to do something about it. Well, that's lovely. Let's give that a go then. Now, latency mon looks at the DPC latency of your system. DPC latency is the time it takes for a driver to do its business, to address the CPU and get a response. Badly written drivers may say hello to the CPU and get the answer and then hang on for too long. And as it's hanging on, other processors are backing up, and that's the situation where you get audio glitches. So with latency monitor, what it does is looks at your system, runs a bunch of tests, and will tell you if there's a driver which is behaving badly, which is great. However, on the Surface, it's completely in the greens. So there you are, all the process latencies are all in the greens. It's fine. This is not the issue. There isn't a driver in the system particularly which is causing an obvious problem. We can now put that away because that's been done. If we're talking about getting the best performance out of the Surface Pro 2017, then really we're kind of talking about tweaking Windows. Now, I've done other videos on tweaking Windows. The one on tweaking the Surface Book and the Surface Pro 4 is absolutely applicable to this. But I felt it was important to point out just a couple of really vital tweaks without which your system is kind of going to glitch and going to pop and not do very well. So that seems important. Let's do that. As I say, for the full details, check out the full video, but here's just the quick one. So go down to the start button at the bottom right, click and go for System. Now, because this is a latest version of Windows 10, the Creators Update, the Microsoft have messed around with all the settings, so now we get a lot more of the settings in this modern UI as opposed to in the old school sort of Windows XP control panel style. You need to go to System Info, which is up over here. That'll then give us our more familiar system panel, and from here you need to tap on Advanced System Settings. In here, tap on Performance Settings. Now, there's some visual things you can turn on and off if you like. They're not really vital as far as the performance of the system goes, but what is important is that Advanced tab. You need to set Adjust for best performance of background services. You need to stick it on background services. That's going to ensure that the driver for the audio interface is prioritized. The next tweak is in power settings. This is probably the most vital. So again, if you right click down on the Windows button and then go to power options, again they've converted this into the modern UI, which is fine, but we don't want anything here. We want additional power settings. This has to be set to high performance. Now, it's possible that you do not have a high performance setting here, that it's just not available, and that is a bit of a problem. In order to make that appear, you have to turn off something called CS enabled. CS enabled stands for Connected Standby. It's kind of all of the the power functions of the system, and we really want to turn that off. And in doing so, it gives us access to the high performance mode, and it gives us access to a lot of the internal additional settings which we need to play with. How do you get to CS enabled? Well, I'm just going to have to go through it, aren't I? Tap your Windows button, type in regedit. Then you're going to want to go to local machine, system, current control set, control. Scroll down to power, and then over here, CS enabled. Double click it, set it to 0, hit OK, and reboot your system. That should then provide the high performance option and the additional options. Let's have a look. So once you have that, tap on change plan settings. The turn off display thing, always set that to never when plugged in. Now I'm using this entirely plugged in. I'm not doing anything with battery at the moment because that's a whole different thing and lots of other different things come into play. So for this, we're always having it plugged in here, right here, plugged in to power, because that's going to give you the best results. Tap on change advanced power settings. Now in this little window here, when I first got my Surface Pro 2017, this list of stuff was not there, did not exist. I disabled CS enabled and went straight in here in order to set it up, and these were all missing. However, they have just come back. In an update I did like a week ago, these have all reappeared. So which ones do you need? Well, first of all, turn off hard disk, put that to 0 on plugged in. Under USB settings, selective suspend, put those to disabled. And then the important one is under processor power management. Now, under minimum and maximum processor state, that has to be set to 100%. That is a very vital setting. That's about it. Once you've done that, hit OK, maybe reboot your system. It's always a good idea. And you will be good to go. So before we start pushing the boundaries of what's possible on the Surface Pro, I just wanted to demonstrate all the bits of software that I have running their own projects, just so that we can say, yes, it does work. And then we'll move on to some really intensive testing. It was live. Pro Tools.
You're only human, but just look what you've done. You hang your head like a child. You can't conceive of.
Reason. Waveform. Now, as you can hear there, Waveform has a few glitches in it. I mean, this particular project seems to be kicking it up into 70–80% CPU, which is unfortunate for a demo song, I would say. I mean, I haven't looked into this in any great depth, but I know that if I disable one of the biotex, for instance, that it seems to calm itself down and sort itself out. And those biotex synths are particularly CPU intensive. There's a lot going on in there. So it may just be that. I don't know, but I'll have a further look into Waveform at another time. But suffice to say, it's playing back all right. It's just the demo project is just a little bit too meaty, I would say. Bitwig. Studio One. FL Studio.
Why is so grey.
FL Studio also introduced the odd little glitch in there, which again may be down to the intensity of the project, but just a couple of tips if you're an FL Studio user. If you go to the general settings, you want to take off or uncheck ultra smooth and force refreshes here. I believe that seems to sort out a lot of the issues you may get with FL Studio, just to focus its attention back onto the audio stream. But as with all the others, I'll be giving each DAW a lot more individual attention in separate videos over time. So we'll be able to get into the guts of FL Studio and all the others to see what they're about, to see how best to coax out the right sort of performance and the best sort of performance, and to see how far you can take it. I'm fairly confident, I hope you're fairly confident, that the Surface Pro 2017 can absolutely run the DAW software that you want to use. How much it can do, how far you can push it, well, that's a whole nother question, and that's the one that I'm going to look at now. Let's get to it. I'm going to jump straight into Dawbench. Now, Dawbench is a really useful project you can get from dawbench.com that provides a Cubase project and a plugin so that you can run that project and see how many of those plugins you can run on your system, and therefore create some kind of benchmark for your system. Benchmarks, as I say, they're not always very useful, but what can be useful is the way that it can show a comparison between two different systems or two similar systems. I mean, it's gone a long way to demonstrating how the performance of audio interfaces can vary enormously, and even on the exactly same system, two different audio interfaces can produce radically different results. And I'm going to use it here because it's an accepted test and it will give you some idea of the performance of the Surface Pro. Now, what it will do is show you how many of this particular plugin with this particular audio interface at this particular buffer size will be able to run. You can then extrapolate from that all sorts of things, but all it's showing is this exact situation. You may get very different results on your system, on your Surface, with your audio interface at the buffer size that you use. But what we will be able to look at is how many sort of plugins it can do. We'll be able to compare it to the Surface Pro 4 under the same conditions, and we'll also be able to look at how the Surface Pro reacts to running with its CPU maxed out. Does that have an effect? What happens when that happens? What happens to the thermals when it starts to get hot? Does that have an impact? We can look at those sorts of things within this test. Now, in the new 2017 version of the Dawbench project, there's a new plugin that they're using, something called the SGA 15301156 or something of that matter, which is a much chunkier plugin. It uses much more CPU for every instance, because computers are getting so fast now that you can fill up all the slots using the original one they used to use, and so you need something meatier in order to produce better results. So I'm going to use both just to see what happens. We'll start off with the old-fashioned one, the RXC plugin, and see how many of those it can realistically run. So in Dawbench you have a simple audio project which is running alongside 40 sine waves, 40 tracks which are just purely sine waves, and it's on those that you're running the plugins. You're not listening for the effect of the plugin, you're just listening for the crackle that happens once your system has reached as far as it can go on successful audio playback. That makes sense? So on this project here, I've already been using it and I've already enabled a whole load of these RexCom plugins. And as I scroll through here, you'll see that I've got two of them enabled on a lot of tracks, up to about track 20, and then one enabled on all the rest. So in total at the moment, that's 40 tracks, that's 40 plus 19, that's 59 of those particular plugins, which is all right. As you can see, the VST performance meter is up, but all the proof is in the pudding when I press play. Now, as you can hear, the playback is fine. It's perfect. There's no glitching, no anything going on. Nothing is happening here that's pushing it up into the red. That's good. So that's 59 plugins. That's not a bad start. Let's see if we can enable some more. So we're now up to 65 plugins, which is looking good. Oh! Okay, and then it bombed out just as I moved the mouse. So now what we need to do is go back and disable them until we get proper playback again. Okay, so now we're back to 60 plugins again. Possibly 59, because that just glitched again. Which is interesting. So why was I able to go up and now I've had to come back down again? Well, if we look at the Intel monitoring software, maybe this will tell us something. Now you can see here that when we started playing, is here. You can see how the CPU utilization is really high. That's because we started the playback and it all shoots up. And down here, you can see that also the core frequency went up. So I bring my mouse in, it'll show us that at this point, the processor speed went up to 3.14, 3.16, 3.27, 3.3 it peaked at 3.3. And at that point, we were loading on more plugins and getting more space to play. And then suddenly, it drops. It drops back down to 2.6. And then gradually it's working its way down to 2.5. Now you can also see that that happened when the package temperature got up to about 80 degrees here. It all sort of correlates. So the Surface Pro is throttling down the speed of the CPU as the temperature hits a certain point. But what it also did is it threw it up to 3.3. I mean, in some ways that's quite mad. I mean, this is a 2.6 gigs processor, I believe, with a turbo to 2.7. So let's run the project again and see if we can capture that temperature change and what happens on film. Okay, so it's already feeling fairly sorry for itself. But that's because at this instance, the frequency has dropped to 2.4. So previously when it was at 2.5, 2.6, it was able to handle this particular project. Now the CPU's dropped to 2.4. Why is that? Well, it's possible that it's because it's quite a hot environment in here because I have these lights and stuff going on, that maybe the system is still seeing itself as being a little bit too hot and so is clocking down the processor. Now I need to stress that this is nothing like the throttling we saw on the Surface Pro 3 many years ago. That would just go wham back. It would halve the CPU frequency, completely destroying your project. This is eking down a little bit. Let's see if I can free up a couple of plugins to see whether that recovers it. Okay, now back to 52 plugins, but the processor speed is still on a bit of a downward trajectory towards 2.2 now. Now the question of course that raises is that this is a passively cooled Surface Pro, and so the system is designed to recover from high temperatures. If you're caning the CPU, if you're running the CPU at its maximum, it's going to get hot. And without a fan to cool that down, its only option, if it gets too hot, is to clock down the processor. And that seems to be what's happening here. Now I'm a little bit perplexed here because in the majority of my testing, this didn't happen. At the moment, it's dropped down to 1.4, which is ridiculous. That's no good at all. So it may be, because I've been doing this all day, I've been filming all day, that it might just be at the moment running really hot in the background. In fact, if I touch it here, I mean, it's very hot. Even though the package temperature only says 50 degrees, that's not actually what Microsoft takes as its measurement. It has its own thermal something or other in the back here because it needs to take an overall, not just of the CPU, but of the overall system. So that has to be why it's clocking down, which means I'm going to have to bring in my friend, the fan, to see whether that can sort it out. I mean, this is a shame. This is built as a passively cooled system, and so it should be able to handle the CPU being used. But as I say, maybe this is extreme circumstances with my lights all over here. The fact I've had it running all day in this place, I don't have any aircon on or a fan on because I don't want the noise when I'm making the video. So it's very hot in here. But let's see what this does to see whether that's interesting and to see whether that's a way of recovering your system if it does get too hot. There we go. So I'm going to stick that up. Try not to shave my fingers off. Ow! I'm going to angle it on the back about there. Let's see whether you can see that. So it's just there. And let's see if that makes a difference. Now remember, the processor is still heavily utilised because all those plugins are running. I haven't pressed play, so they're not being fully utilised, but they are still there. So the system is still going to run at quite a high CPU usage. And particularly now, as it's come down to 1.2, you know, almost the entire CPU is used up. Can you see here how it's now starting to bend back up again? The same project, the same amount of plugins are loaded, the same processes that the processor has to accomplish, and now we're back up to 1.36, 35, 36. So we're now back up above 2 gigahertz, which is very interesting. It's crawling back up quite slowly because, I mean, the fan I've got on the back is a simple USB one. It's very quiet, and actually I'd be quite happy for that to be there if it meant my project is going to run more efficiently and better, and the performance is going to stay. 2.28. So as it continues to climb, I feel I really should stress that this doesn't happen normally. I mean, as I say, I've been doing days and days and days of testing different things, and the majority of the time the processor speed stays around 2.5, 2.6, sometimes going higher up to 3, up to 3.3, and sometimes perhaps down to 2.4, but rarely. It's been very consistent within that range. So this is an unusual thing to capture, and I hadn't expected to capture it in this video, but it happened. It's here. My only explanation for it is the temperature and the ambient and environmental temperature that I'm working at the moment with these, as I say, with these lights, and in a situation that I am where I have no air coming in here at all, and we're all going to turn into sweat spots and die. But look at that, it's back up to 2.5. It took a little bit of time, but we are there. Now let's see whether shall I risk playing the project back? What do we think? Give that a go. So now it's back up to 2.6. I'm going to see if I can get some of those plugins back in. Yeah, it's good, and that's where we started. That's with 59 plugins loaded, which is where we started all this mess some time ago, and it's holding completely steady. So some unexpected thermal nonsense going on there. I will reiterate and stress again that in my experience of using this over the last couple of weeks, I didn't hit that problem. I didn't hit it in normal use without lots of lights and stuff on and a little bit more air in the room. That wasn't a problem. I believe the Surface Pro 2017, the i5, is capable of running passively. I believe it is in the right environment. However, in a hot environment, you might run into a little bit of trouble, and a little fan like the one I've got on the back here, will sort it out. Is that the end of the world? I don't know. I thought Microsoft were really ambitious to take the fan out of the system. You know, I kind of thought that's not going to be a good idea. But it nearly is, and for the vast majority of users, it will be completely fine. Just gets a very hot back, that's all. But for us idiots trying to cane the CPU in crazy projects, then it may be an issue. But there was another way that I found that made the CPU much more stable. Because earlier on, when we started this project, we talked about it going up to 3.3 and how that was great. So you could load more plugins and then it clocking back down to 2.5, 2.6, and you losing that headroom that you thought you had. Now that can be really annoying in a project. There's nothing worse than being able to expand in something and then suddenly not being able to run the same thing again. So is there a way of fixing the CPU at a set frequency? Yes and no. Let's give it a go, particularly in my slightly messed up situation here where the temperature is a problem. The place where you do it is in the power options. If you go to additional power settings, high performance like we saw before, change plan settings, and then the advanced power settings, we are going to do something in here. Now I've done this before on other systems, particularly on the Surface Pro 3 when I wanted to prevent the thermal throttling. What you would do is set the maximum CPU up to about 90% so that it wouldn't actually go that high, so it wouldn't generate that much heat and you wouldn't get the throttling. That was kind of a a good, wise way to use the Surface Pro 3 with sort of mid-level projects. So you weren't pushing it all the way, so you didn't need to have absolutely every single cycle. So if you brought the processor speed down a little bit, it was less likely to heat up, less likely to throttle. Now with the Surface Pro 2017, what I've found that if you set the minimum and maximum processor state to 99, that prevents it going up to the 3.3. It doesn't seem to do it. It gets stuck at about 2.5 something. We'll have a look in a moment. But in my testing of this, setting it to 99, it's stuck more or less almost completely flat at one frequency. Now, I'm not sure how the thermals are going to affect this because I haven't encountered it in this way before, so I'm doing this just off the cuff. But I believe setting it to 99 could be a good way of keeping the processor more steady so that your projects can be more consistent, so that the power can be more consistent. So you're not having to cope with this rising in gigahertz, this sort of turbo mode, and then dropping away, messing your project up. Does that make sense? Let's give it a go. So I'm set it to 99%, I'm then going to reboot, because that's always a good thing to do. And at the moment it's sat on 2.5, 2.52, 2.50, and you can see the line here that it's following is pretty flat. Pretty flat. And this is with this project loaded. You can see at the point at which it got loaded, which is here, and it's staying pretty flat. Let's see what happens when we run it. At the moment I still have the fan on the back because I don't want it to be a thermal issue. Not yet. We want to look at it first as if there is no thermal issue. So you can see that the CPU here is at 100%. But even so, the max core frequency is stuck at 2.58. You see, that's really interesting that it stayed completely flat. Since I started press play on the project, it stayed completely flat. Nothing is going on. The temperature is kept under control by the fan at the back, so everything is completely stable, which is very interesting. Now I wonder what happened if I pull out the fan. Well, you know, I'm of the belief that in a normal situation where you have normal airflow and normal cooling, the fan is irrelevant. It shouldn't need to be there. In my hot environment, it seems that for the moment I need it. But let me take it out and see how that affects the playback. Well, as you can see, I've been running it for several minutes now, and although the package temperature is climbing very, very slowly, it is very slow. And the CPU frequency is absolutely static on 2.58. And the CPU utilization is still up between sort of 95 and 100%. So I think if I left this running perhaps for another half an hour or so, it may well tip it over the edge. And maybe what we saw earlier was just the result of a long period of time of really caning that CPU that caused it to hit that thermal problem. And I completely, so it seems, solved it through the use of my fan. And now the system, there's no fan attached, there's no system, it's purely passively cooled, seems completely sweet, operating at this level of CPU utilization and temperature and everything else. It's completely sweet. So I think what I'll do is I'm going to carry on the rest of my performance testing and demonstrations with that 99% CPU usage. To have it stuck at 2.58 to me seems absolutely ideal. So I would much rather have a steady CPU speed than one that can climb a little bit higher. I would rather compromise and have it running slightly slower than have a system or a situation where the CPU is going up and down. Shortly after the thermal event that we had yesterday, my wife walked in and remarked, "Cool, blimey, it's hot in here," and also that it stank a bit. So it seemed like a good time to call it a day and maybe start afresh. And that's where we are now. It's a new day, it's a new shirt, and I'm ready now to do some proper performance testing. Just as a reminder, I've restricted the Surface Pro 2017 to that 99% of the CPU, so it's running at about 2.58, 2.59 gigahertz. Running with the ReXCon plugin, we can see that we get 59 plugins running. Temperatures are fine, core frequencies at 2.58. It's all sweet. If I add another plugin, it'll fall over. So 59 seems to be the number that this system is capable of. Right, I want to do a couple of quick comparisons here just to demonstrate something. And that's how it makes no difference whatsoever how you connect the audio interface to the Surface. I've had a few comments about how you shouldn't use USB hubs and that reduces performance and you need to have the thing plugged directly in. So I thought I would quickly demonstrate how that's not the case. So first up, I'm going to use this little device here, which is the Surface Dock. It comes with a few USB ports, it comes with Ethernet and some video outputs as well. It's a very useful device. I dislike it because it's very, very heavy and comes with this, which is the power supply, which is the same size. And that just annoys me in lots of ways I can't really explain. And also the connection to the computer is this big whopping great thing that sticks out the side and is very easy to knock and nudge. And it doesn't have a very long cable, so you can't sort of put this up out of the way anywhere. Anyway, I digress. So this provides USB ports which are directly into the Surface and also some which provide on a hub. So I just wanted to see if that made any difference whatsoever. So my fast track is now plugged directly into here and we have the connection of the power supply from the dock to the Surface. That's how it connects up. Let's see how it does. As you can see, the performance is exactly the same. It's identical. I can't get another plugin in there and it's running fine on 59 plugins. Now I've plugged the fast track directly into the side of the Surface, into its only USB port here, so the audio interface is connected directly. I've also had to keep the dock attached because I need another USB port for my dongle, which is here. So that's all connected directly in. Let's see if there's any difference. And no, again, it's exactly the same. So I would just like to summarize that by saying that however you plug your audio interface in, whether it's via a USB hub, whether it's by the Surface dock, or whether it's directly in the side, the audio performance, the measurable audio performance in Cubase is negligible. There's nothing there. There's nothing in it. So you don't need to worry about how you're connecting it in. That should not be a factor. I'm going to do one more plugin test with the newer Dawbench plugin to see how well that fares. Currently I have 31 of these loaded and that seems to be just about the sweet spot I think. We'll have a look at that in a second, but I think this neatly highlights a difference between plugins. I mean, when somebody asks me, yeah, how many plugins can it run? How many plugins? Well, it depends on the plugin. Can I run 20 plugins? Possibly you can. Can I run 40 plugins? Well, you can of the ReXCon one. You can't of this one because plugins take up different amounts of CPU, power and space in order to run. So it's a completely how long is a piece of string type question. It's impossible to answer. And that's, you know, some of the reasoning behind doing what I'm doing here. This enormous video I'm trying to produce is to demonstrate, to give you an idea of how many plugins it could run so that you can then take that, use your brain to apply that to your own sort of projects and have a fairly good idea as to whether they're going to run well or not. Let's see. So that's 31, but it looks to me like there might be room for another one. Now my CPU is dead on 2.58, which is really good. That's where I want it to be. And because it's not anywhere near so hot in here, it should maintain that indefinitely. So I'm going to push it up to 36. Now you can rest assured that by now I hate this Dawbench song far more than you do. So just stick with it, we're nearly done. Okay, so at 37 it just tips it over the edge. But I think 36 plugins, that looks pretty good to me. That's going to be the number we'll use and take forward. And what I'm going to do now is switch to the Surface Pro 4 and see how well it compares. So welcome back, my old friend, the Surface Pro 4. We've been through so much together over the last year where it was all just horrible, and now it's far, far better. With the Surface Pro 4, what's interesting is that the power options are set to 100% minimum and maximum. And what we find is that the CPU stays at about 2.9. As you'll see here, 2.93, 2.94, it does vary a little bit, but it stays at about that maximum. It doesn't shoot up into 3 point anything. It doesn't seem to drop down. I mean, it's a lot less prone to thermal issues because it has the fan in the back. Although I did do a bit of testing on this yesterday when I had my super perfect storm of heat in here, and it did struggle. With the fan going like crazy, it still had to clock down a little bit. So I was baking in the shed last night. But under normal conditions, it sticks at about 2.9, which is going to be interesting. Let's see how that fares against the new Surface Pro 2017 with its Cable 8 processor, running, as we know, at about 2.5, 2.6. Let's hear that song again. Now the load is up pretty high. It looks all quite well behaved at the moment. Let's just check the temperatures. Yeah, it's at 2.9, fiercely straight at 2.9, and with around 94–95% utilization. That's now up to 66 plugins, which looks like that's about as far as it's going to go. Still completely set at 2.9. CPU utilization is up to about 100%. So I think we can settle there at 64 plugins. So that's 5 more plugins than the Surface Pro 2017 did. Why is that? I mean, this is a Skylake processor. The Surface Pro 2017 is a Cable 8 processor. Surely it's far more advanced. Well, yes, it's a more advanced processor, but all the advancements tend to be in terms of efficiency, of power efficiency, and how well the CPU works in mobile situations. In terms of raw processing power, it's going to be much more down to the speed of that processor. And on the Surface Pro 4, it's stuck at 2.9, which is great. On the Surface Pro 2017, in order to keep it stable, I've restricted it to 2.5, 2.6. And so that difference of 0.3, 0.4 gigahertz is being borne out in the difference between how many plugins it can run. Now, I don't think that's the end of the story. I don't think it's all going to be ever as simple as all that, but it's an interesting comparison in how much more stable the Surface Pro 4 has got over time compared to a very recently released next generation Surface Pro. Here we are with the Shattered Glass plugin project. I can hear the fan on the Surface Pro 4 now starting to whine up and kick in order to keep the temperatures under control, which is interesting. That is not something we suffer from on the Surface Pro 2017. No. It just gets really, really, really hot. So let's try this out. This is on 36 plugins. So it just started to glitch on 40. If you can hear a general, that's just the rain on the roof, which, because it's August, you know. So I'm down to 37 plugins for reliable playback, which I think is only 1 or 2 more than the Surface Pro 2017 did. So a lot more comparable, but then this is a much chunkier plugin and takes a larger load of CPU to run a single instance. So there you are, Surface Pro 2017 versus the Surface Pro 4. At the moment, the Surface Pro 4 just has the tiniest edge, which is mainly down to its ability to run a stable processor speed of 2.9, whereas with the Surface Pro 2017, the stability seems to be at about 2.5, 2.6, because I have restricted it to that because of the turbo mode kind of messing us about a bit too much. So in reality, in most situations, the Surface Pro 2017 is more powerful than the Surface Pro 4 because it has this extra headroom in the turbo space. I'm just not convinced that that's useful for us in music production. We would be much better off with a stable, flat, known value for processor speed. But as the Surface Pro 4 got remarkably better over time as they released updates for it, hopefully the Surface Pro 2017 will receive some similar updates to perhaps allow us to use more of that CPU headroom, which is available there. It's just a bit too up and down for us. People often ask me about the power of the Surface as kind of a live performance VST instrument sound source. It's a good question. I mean, it's an ideal platform for running virtual instruments because of its touchscreen, the ease of getting to controls, and it's very portable, you know, and all those sorts of things. So it's a very good question. And previous versions of the Surface have kind of shown that it can do it, but it's not really its favorite thing. We tend to find there's two forms of VST instrument. There's the CPU-based ones, which are using synthesis or modeling in order to create the sounds. And then there's sample-based ones, which draw on a sound library to create their sounds. And I would like to sort of demonstrate both. I'll start off with the Arturia ones, which are all CPU-based, and then I'll move on to Kontakt and some sample-based sounds, before finally doing a little bit of sort of measurable polyphony testing in Cubase. So I'll kick off with the grand piano from Arturia, which is kind of notoriously CPU intensive really. I'll be using my Novation bass station here as my MIDI controller. I've also got a sustain pedal on the floor, which you can't see, in order to push the CPU, because when you sustain notes, it's much more for the CPU to do, and so it's much harder, and etc, etc. And what we're looking for is whether you can get playable usage out of these things without any glitches. That's more or less it. The Arturia grand piano down here is a CPU meter at the bottom, which usually gets up to about a quarter full. But in my playing with it, I've found no glitches, no problems at all. Perfect playback, no problems, nothing going on, it's just good. So it's good and it's solid. Now you can do the same with all the Arturia synths, but I won't bore you with that. But what we will look at is Analog Lab. This gives you access to all of the Arturia collection instruments and also allows you to combine a couple. So here I've combined the grand piano with a Jupiter 8, just to give an example of how you can put two together and the Surface can still cope with it. So again, completely perfect. And you know, the other awesome thing is that you have touch control over everything very easily. You can set up macros down here that control different things. You can assign them to whatever you want, and it's very, very touchy. Now, there are some elements within Analog Lab that are not touchy, like some of the menus, which is a real shame. It kind of trips up when you actually try to save it. You have to drop back to the mouse again. But the majority of the controls are all very, very touchable, making it an ideal platform for the Surface. So yeah, I hope you can see there that it's completely capable of running live instruments live. I'm running at a buffer size of 128 milliseconds, which is giving a latency of under or around 5 milliseconds, which is perfect. Perfectly playable. Perfectly playable. And the performance is excellent. I mean, you can force it to crackle if you really slam on all the notes all at the same time with its sustain pedal on until it goes all the way to the top. But why would you do that? I don't know. Moving on to Kontakt. I haven't done many videos on Kontakt in the past. I've generally focused on Reactor 6, which works brilliantly on the Surface, and I've focused on the Arturia synths. But I'd like to have a look at Kontakt because that works differently. It's a sampler. It uses sample-based instruments which are drawing their sounds off the internal hard drive. I have no external drive attached to this. It's all installed on the internal 256GB drive, which if you have, for instance, Complete 11, is not going to be enough. But for the select instruments that I'm using here, it's more than enough. And I will at another time investigate external hard drives and sample streaming and that kind of thing on the Surface. But that's not now. Now I just want to have a look at playing stuff which is installed locally to see whether that works. So I have the Alicia keys loaded. Let's give that a quick bash. Now in Kontakt it has this nice helpful voices meter at the top, which shows you how many voices are playing and also the sort of CPU you're using, as well as the amount of samples that are loaded. So playing a lot of notes, I can get up to about 100 notes of polyphony with no problem. So what I'd like to do is add some strings to this. So I've got the Pro strings installed, and I'm going to throw in an ensemble alongside. But again, no problem. Let's add some more strings. So now we're getting sort of polyphony up to about 160 and CPU up to 3040 with 1.2 gigs of samples loaded. Right, let's stick some violins in over the top. Let's add an articulated string section in with action strings. Going to add some violas. I think that'll do, or I could be here for a long time. I mean, it's going up to 50-60% CPU. It's going up to about 300 notes polyphony, 300 voices, all sounding all at once. I think that demonstrates quite aptly that within Kontakt you can have some large instruments loaded. You could be doing some orchestral work on the Surface. Now, it's not exactly best suited for heavy orchestral work. I mean, for that you probably need separate hard drives on a big desktop computer, or two desktop computers if you're into sort of Vienna symphonic libraries and East-West stuff and those huge orchestral libraries. Then this is probably not the machine for you. However, as you can see, I've got all the string sections of the orchestra loaded and playing all simultaneously, all at once, with a piano stuck in there as well. I've got nearly 2 gigs of samples loaded. That's all pretty decent for many people in many situations, particularly if you were playing live and you just wanted some piano and some strings and some bits and pieces. Yeah, totally. It can totally do that. Back in Cubase then for my polyphony test. This is my Halion polyphony test. You might have seen it before in previous videos that I've done. The idea is that you play 8 notes into a loaded instrument and then hold those notes for a period of time to see whether it crackles. So it builds up the CPU usage as those notes are added. And it seems to me to be quite a neat way to measure the sort of performance you can get from virtual instruments. This uses Halion. Let me show you what it looks like if you're not familiar. There you are. This has got a cello loaded, and I have a single instance of Halion loaded for each instrument. I haven't done multiple instruments within one. I've loaded a brand new instance every time. Here's the sequence of notes. 1, 2, 3, 4, 5, 6, 7, 8 notes all going individually and then being held. Currently I have, would you believe, well, I've got 64 of these loaded, but the enabled ones, I'm enabled all the way up to 43 tracks of MIDI I've got going on, playing into 43 Halions. Right, let's give that a go. This is what it sounds like. So you can see the CPU meter climbing as those notes are played. You can see that it's almost up to 100%, and now the screen is struggling slightly to redraw the timeline as it goes along, and other bits and pieces as well. So it seems to be coping with that all right, which is cool. That's 43 instances. If I add a couple more, maybe we'll see what happens at that point. Yeah, it's just starting to glitch now. It's just slightly overwhelmed. Now I know that 45 instruments is just over 800 voices, so that's pretty good going. That's a lot of virtual instrument potential going on in there. And if you have Cubase and you'd like a copy of this project, because it's just a simple Cubase file, there's no audio involved, it just loads up Halions and off you go, then just drop me a line and I'll send it to you. No problem, you can try it out for yourself. So then I thought, why don't we do the same with Kontakt? Now with the Kontakt test, I've done this in a slightly different way. I've loaded a single instance of Kontakt and then added instruments in it, like when I was playing live. but I'm going to run that same sequence into it to see if there's a point at which it all packs it in. So I currently have loaded the Alicia keys, the sections 1 and 2 ensemble, the sections 1 and 2 cellos, the violas, the violins, and then the M-Town sections ensemble, the cellos, the violas and the violins, all from the Session Strings Pro library. Now you can see that it is maxing out. I mean, in Kontakt it says it's over 80% CPU, and the performance meter in Cubase is maxed out as well. When it rotates, when it does the loop, there tends to be a bit of a glitch there, so it's kind of getting to the end of that long sustain and then doesn't quite hold it together on the repeat. If we look at the temperature is at 2.58. It's steady since I've been playing this, so the temperature and the processor speed at the moment seems to be nice and stable. You can see at the top here, it's doing over 500 voices. Now I think it's fair to say that we were really pushing on that, and perhaps it's at the end of what it can do. And if you were to ease off a bit, you can have a lot more headroom. So I mean, as we've found with all the Surface products, really your operating space is up to about 70% CPU. Once you get above that, it starts getting a little bit dicey, even though I've shown it working up to 80, up to 90, 95% CPU. The ability for the computer to work, for you to move windows around and do stuff, becomes seriously impaired at that kind of level. But what I'm trying to demonstrate is how far it will go, and hopefully you can take from that how much you can do on your own system, or rather how much you could do if you decided to go for a Surface Pro. And finally, I wanted to sort of pull it all together to put together a musical project which has some kind of musical reality to it. Because the problem with benchmarks and notes going through and the constant cycling of that Dawbench project is that there's no musical reality to it. You're just measuring how many plugins are running to a set number of notes. There's no change, there's no automation, there's no stuff coming in, stuff going out. So it doesn't really represent anything in terms of how you can make music on the Surface and how a realistic project would respond. So what I wanted to do is to have everything, to have audio tracks with effects, to have instrument tracks all running and changing and automated, both CPU-based ones and sample-based ones, so that we could see the sort of size project that you could potentially run. Now, I must stress, as I always keep stressing, that it depends on the plugins you are running. Now I'm going to run some fairly intensive ones alongside some perhaps simpler ones. So it's just to give you an idea. Yeah? So starting off, in my project, I have 16 tracks of audio. So every single channel of audio, all 16, has one of Cubase's quite intensive new frequency EQ things. It has VST dynamics, compression, etc. And it has a reverb running on it, the Revelation reverb. So big chunky plugins. I've got 16 of those, one each on each channel, all working at the same time. So that's 3 lots of 16, 32, 48 plugins running on audio channels, and we haven't even started with the VST instruments yet. On the VST instrument side of things, we have a Kontakt running some strings, we have another Kontakt running some more strings, all from the Session Pro again. We have the Stage 73 Arturia electric piano. We have the SEM from Arturia. We have a Reactor 6 running a load of blocks. We have a second Reactor 6 running a Razor, which is rather nice synthesizer. I've got a Mini Moog, of course. I've got another Kontakt 5 running some action strings, because I really like those. I have the Arturia Jupiter 8, which is a well, mighty and meaty synthesizer. And then finishing it all off, I've got Alicia Keys piano in Kontakt. So in total, that's 10 fairly hefty virtual instruments running alongside 16 channels of audio with those 48 plugins. That's a lot of stuff. And it's both sample-based and CPU-based. You know, it's going to really work the Surface. But let's see if we can get some decent playback. So although the VST performance appears to be around 50–60%, it's actually more on the edge because there's this real-time performance meter at the bottom which keeps peaking up, which is probably going to be to do with sustain notes and the processing on that kind of thing. If you're wondering where all the audio channels are, they're here. I've just turned them down, that's all. They're all playing. A bit distorted now, so I turned it up too far. Yeah, you getting all that? That's awesome, yeah? Looking back into our temperatures here, it's now the middle of the day and I've been doing this for 4 or 5 hours. It's very, very hot again. So the environment in here is starting to affect what the Surface Pro can do. So it's just starting to clock it down a little bit. So rather than being at 2.59, it's now at 2.53. So that's why we're starting to get a few glitches introduced. So there you go, there's a musical project in Cubase on the Surface Pro 2017 with 10 virtual instruments, sample-based, CPU-based, 16 tracks of audio with 48 plugins, dynamics, reverb and EQ, all applied to all of those channels in real time, simultaneously, playing back like it's a music making machine. That's pretty awesome. So there you have it, very interesting. What do you think? Is it up to the task of being a music production studio, do you think? Well, yeah, I mean, honestly, to a degree, that's always going to be the answer. First thing to point out is that it absolutely works with every single piece of software that I tried. So it's already, with a couple of tweaks, ready to do music production. We had none of this ease of entry with the Surface Pro 4, if you remember. So the Surface Pro 2017 has given us the ability to use the vast majority of its CPU cycles for music making. And that's awesome. It means that we can now concentrate on using it as a creative device rather than concentrating on trying to work around issues and problems and getting to the bottom of bits and pieces. I mean, as it is now, it's not completely perfect. I've had to restrict the CPU down just a little bit in order to keep it stable for what we need it to do. And that may change over time, so that's something we're going to have to continue to look at. It's true that the Surface Pro 4 at the moment just has the tiniest edge on it, but that's because the Surface Pro 4 is happy at 2.9 GHz, whereas this is running at 2.59 GHz. And that difference in speed, regardless of this being a next generation Intel processor, has an impact. But I imagine over time with further updates, that should improve. And we should get to use more of that turbo headroom. The thermal event was very, very interesting. I hadn't expected to see that, but it is, I mean, a reality of a passively cooled system. I mean, this is brilliant. I love the fact that it's passively cooled. Whenever I start up the Surface Pro 4 and start fiddling with that, I become far more aware of that fan because I'm used to running without one at all. And in normal circumstances, in a normal environment, you are not really, I believe, going to hit those thermal problems. And if you do, well then, you know, a $10 fan stuck in the back is going to sort it out. So as a first attempt at a passively cooled i5 Surface, I think Microsoft have got it nearly almost damn it right. So can you run huge projects with masses of tracks and a gazillion plugins? No, you can't. That's what a desktop system is for. That's what a Studio Pro Core i9 is for. This is going to run something more modest. It's going to deal with live performance really well. If you want to perform with virtual instruments, it just eats that up. It has no problem with it at all. You can layer up all sorts of stuff. The masses of polyphony I was getting, all of that is awesome with very high quality sample streaming and CPU based instruments, the kind of stuff that the iPad can only dream of. So overall, you know, I think the performance is good. It's not impressive, it's not wow, because it's an Ultrabook. It's got the sort of processor in here that has no business running music software, and yet that is what we're doing. Why the Surface? Why not some Asus or Lenovo box? Well, because I just love the lines, I love the form factor, I love the kickstand, I love the touchscreen, I love the fact that it's a Microsoft product because they produce the operating system that runs on it. That appeals to me, and it's just a beautiful thing. It really, really is. So I hope that's been helpful, and I hope that's enabled you to see what could be possible on the Surface Pro 2017. From here on in, I'm going to start making videos on individual DAWs, individual bits of software to show how well they work, their sort of performance, along with how touch works in them, how the digital pen works with it, and to try to get the best creative use out of the Surface Pro 2017. Until next time, go and make some tunes.